Specialization describes a relationship in which one class or subclass inherits all the main characteristics of another class or superclass. The subclass can also add new components such as attributes, methods, and so on, and replace the implementations in inherited methods. In the latter case, the method name in the Unified Modeling Language or UML diagram is renamed within the subclass. Specialization is an implementation relationship that emphasizes the similarities of the classes. In the above example, the common components of classes LCL_car, LCL_truck, and LCL_bus are defined in the UML model in the superclass, LCL_vehicle. The common components of the subclasses only need to be defined and implemented in the superclass, and they are inherited by all the subclasses. Specialization is described as and is a relationship semantically. For example, a truck is a specific vehicle. Reversing the point of view is referred to as generalization. Generalization and specialization provides a significantly better structure for your software because commonly used elements only need to be stored once in a central location, which is in the superclass. These elements are then automatically available to all subclasses. Changes made at a later stage have an immediate effect on the subclasses. Therefore, do not alter the semantics when you change a superclass. You need knowledge of the implementation of the superclass to decide whether the inherited components from the superclass are sufficient for the subclass, or if they must be extended. Generalization or specialization therefore provides strong links between the superclass and the subclass. When you develop additional subclasses, adapt the superclasses too. The creation of a subclass sometimes leads to additional requirements for the superclass. For example, when a subclass requires certain protected components, or when the details of implementation of superclass are required to change because of the method implementations in subclasses. The developer of superclass cannot predict all the requirements that subclasses need from the superclass.
Inheritance must be used to implement generalization and specialization relationships. A superclass is a generalization of its subclasses. The subclasses are in turn different specializations of their superclasses. Thus, additions or changes are permitted in the subclasses, but you can never remove anything from a superclass in a subclass.
Redefinition is when the implementation of an inherited instance method is changed for the subclass without changing the signature. Because the visibility section for the superclass must remain the same, therefore, redefinition is not possible within the private section. When you use the redefinition addition, you will specify a new implementation part for the inherited method. Since the signature may not be changed, you do not need to define the method parameters and exceptions again. Within the redefined implementation part of the method, you can use the predefined prefix superstatic to access components in the superclass. You may need to do this when redefining a method to call the original method of the superclass.
In this example, the two redefined methods provide completely different information. The semantics of the method remains the same. A redefinition as described for the above methods would not be useful in the case of the constructor. In the subclass, either the constructor of the superclass can be used without any changes, or the subclass has been expanded and the new parameters are now required in the constructor's signature. In ABAP objects, the constructor is not inherited like normal methods. Any class can define its own constructor that is fully independent from the definition of the constructor in its superclass. A subclass can even define a constructor if there is no constructor in the superclass. However, when implementing the subclass constructor, it is mandatory to refer to the constructor of the immediate superclass. By doing so, it is ensured that the constructor of class is always executed, whether the created object is an instance of the class itself or an instance of one of its subclasses. Because of this enforced reference of the superclass constructor, the subclass constructor adds parameters to the signature of the superclass constructor rather than completely changing it. In this context, the concept of overloading is of relevance. With overloading, a method can have several definitions with different signatures and different implementations. The concept of overloading is not supported in ABAP objects. The usual workaround is one signature with different sets of optional parameters. In contrast to instance constructors, the runtime environment automatically ensures that the static constructors of all its superclasses have already been executed before the static constructor in a particular class is executed in the runtime system.
If a subclass has not changed its instance constructor, the constructor is adopted from the superclass. The implementation is also inherited from the superclass.
Inheritance provides an extension of the visibility concept. There are protected components, that is, protected section. The visibility of protected components lies between public and private components. Protected components are visible to all subclasses and the class itself. When defining local classes in ABAP objects, follow the syntactical sequence of the public section, the protected section, and the private section.
The components inherited from the superclass may not be visible in the subclass. A subclass can receive private components from its superclass which cannot be addressed in the syntax of the subclass. Private components of superclasses can only be addressed indirectly using public or protected methods from the superclass, which in turn can access the private attributes. These restrictions are necessary to ensure that centralized maintenance is possible. In this example, it is possible to access the protected constant C_POS_1 in superclass LCL_vehicle directly from its subclass LCL_bus. On the other hand, the only way to access the private MV_make and MV_model attributes from the subclasses of LCL_vehicle is to call methods of LCL_vehicle. These methods have to be public or protected. Using the private section, you can change superclasses without the need to know the subclasses. As long as the changes you make do not affect the semantics, you do not need to adapt the subclasses. This is because they only indirectly access the private components from the superclass. Summary of static components and inheritance are as follows. If you assign a subclass reference to a superclass reference, this subclass ensures that all the components that you want to access syntactically after the cast assignment are actually available in the instance. The subclass always contains at least the same components as the superclass. Always the name and the signature of redefined methods are identical. The user can address only those methods and attributes from the subclass instance that they can from the superclass instance. Note that with redefined methods, the implementation of the subclass is executed using the superclass static type of reference.
Types of a reference variable at runtime in object-oriented programming. Static, dynamic. Note, assignments between reference variables are possible whenever the static type of the target variables is more general or equal to the dynamic type of the source variables.
A typical use for upcast assignments is to prepare for generic access. A user who is not interested in the finer points of the instances of the subclasses but simply needs to address the shared components can use a superclass reference for this access. In the example, a travel agency LCL_rental needs to manage all imaginable kinds of vehicles in one list. To manage all these vehicles in one list, you need to create an internal table and assign it with an appropriate type for the references to the vehicle instances. The car rental company also needs to be able to calculate the required amount of fuel for all its vehicles. In this case, the display_attributes method, which is defined in the superclass LCL_vehicle, must be redefined in all subclasses.
When objects of different classes such as LCL_bus, LCL_truck, and LCL_car are specified as type superclass references, namely LCL_vehicle, these objects can be stored in an internal table. The shared components of the subclass objects can then be accessed uniformly. For this example, you need the method add_vehicle to copy the references to the vehicle types into the internal table. The import parameter of this method is already typed as the reference to the superclass. In this example, the upcast assignment occurs when the vehicle reference is transferred to the formal parameter of add_vehicle method. The shared component is generically accessed within the loop around the internal table containing all of the vehicle references. The display_attributes method was inherited from the LCL_vehicle superclass and may have been redefined. The implementation to be executed when display_attributes is called will depend on which object the superclass reference LO_vehicle refers to. The dynamic type and not the static type of the reference variable is used to search for the implementation of a method. Therefore, when LO_vehicle static display_attributes is called, the implementation is not executed from LCL_vehicle, that is, static type of LO_vehicle, because the method was redefined in all vehicle classes. When an instance receives a message to execute a particular method, the method that implemented the class of this instance is executed. If the class has not been redefined in the method, the implementation from the superclass is executed.
When objects from different classes react differently to the same method calls, this is known as polymorphism.
Using dynamic function module calls, you can program generically in ABAP even without an object-oriented programming model. When you compare dynamic function module call with polymorphism through inheritance, the source code is less self-explanatory and is more susceptible to errors in dynamic function module call. For example, the syntax check can only check whether the function model is called correctly or not. The syntax check cannot check whether the internal table contains a valid function module name for each vehicle or not.
Reference variables of the superclass can also refer to the subclass instances at runtime. You may copy this reference back to a reference variable of the subclass type. To assign a superclass reference to a subclass reference, you must use the downcast assignment operator, move, $2, or its short form $=. Otherwise, you get a message stating that it is not certain that all the components that can be accessed syntactically after the cast assignment are actually available in the instance. As a rule, the subclass class contains more components than the superclass. After assigning this type of reference back to a subclass reference to the implementing class, clients are no longer limited to inherited components. In the example given here, all the components of the LCL_truck instance can be accessed again after the assignment using the go_truck2 reference. Therefore, the view is either widened or not changed. This type of assignment of reference variables is known as downcast. There is a switch from a view of a few components to a view of many components. As the target variable can accept less dynamic types after the assignment, this assignment is also called narrowing cast. Downcast assignments are used when you need to address specific components of instances and keep the references of these components in variables that are typed on the superclass. A user who is interested in the finer points of the instances of a subclass cannot use the superclass reference for this access, because it allows access only to the shared components.
In this example, a car rental company LCL_rental has to determine the maximum capacity of its trucks, but it stores all types of vehicle references in an internal table LCL_vehicle. There may be a problem if there is no truck reference in the LO_vehicle superclass reference at runtime, but the downcast assignment operator tries to copy the reference to the now invalid reference LO_truck. In contrast to the upcast assignment, it is possible that the static type of the target variable LO_truck is neither more general than nor the same as the dynamic type of the source variable LO_vehicle, namely when LO_vehicle contains bus or sports car references. That is the reason why, with this kind of cast, the runtime system checks before the assignment whether the current content of the source variable corresponds to the type requirements of the target variable. Otherwise, an exception that can be handled is triggered, and the original value of the target variable remains the same. You can identify this exception of the error class CX_SY_move_cast_error using try and the catch statement. Another way of preventing this runtime error is to use runtime type identification or RTTI classes. You can use RTTI classes to determine the dynamic type at runtime and set a condition for the cast.
As early as the modeling phase, you should be able to see whether there is a generalization or specialization relationship between certain classes. If there is, you can use inheritance to represent this in ABAP objects. If this is the case, you need to adhere to the relevant concepts of inheritance. For example, the semantics must be preserved when you redefine methods. Furthermore, you must use inherited components as intended in the superclass.
If you do not have a correct understanding of the semantics of is a specific, you run the risk of identifying the wrong places in which to use inheritance. Sometimes the need for another attribute for a class is incorrectly answered with a specialization. For example, the square class inherits from the rectangle class. If you try to define methods for the rectangle that change the width and height separately, these methods will not make sense when applied to the square. Even if the methods are redefined to make the lengths of the sides uniform, the semantics will be different for the same reason, that is, using inheritance only because some required functions are found in a superclass is also not appropriate.